let's look at the balancing of a redox equation in acidic solution. So this is where we would be mixing solutions, but the conditions of the system would be quite acidic, usually by adding excess acid. In this example, we're going to look at the oxidation of Fe2 plus to Fe3 plus by dichromate ions in acid solution. So we're going to start by writing the unbalanced equation in net ionic form. So here is our unbalanced reaction. And what we want to do is separate this into two half reactions. Our oxidation reaction in this case is the iron, and our reduction reaction is the dichromate converting into chromium-3 ions. Now you'll notice that in this example we've recorded the oxidation numbers of the metals, so the iron and the chromium in both of these cases. This is just to show why we know it's oxidation or reduction. When we're balancing, we don't necessarily need to do that step, but it is helpful for verification in future steps. Now, the first thing that we need to do here is balance the atoms. In previous examples, the atoms were already balanced because we didn't have any oxygen involved. But now that we have oxygen involved, we're going to need to balance the oxygen and hydrogen atoms using water and hydrogen ions. So for our oxidation reaction, we're not going to need to do anything on this step, but usually, or in a lot of cases, you're going to have to perform this step on both of your reactions. So in our dichromate reaction here, first we want to balance the atoms other than H and O. So we had to put a 2 in front of the Cr3 plus on the right-hand side. The next thing that we want to do is balance the oxygen using water. So in this case, I have 7 oxygens on the left-hand side, which is why I've added 7 water molecules to the right-hand side. And then next I'm going to balance with H+. I'm going to balance the hydrogen atoms using H+. That's where our acidic solution is coming from. In this case, we've got on the right-hand side 14 hydrogen atoms. So I'm going to add to the left-hand side of this equation 14 H+ or protons. Now, like we did in previous examples of balancing redox, our next step once we balance the atoms is to balance the number of electrons. So we want to add electrons to either side of the equation to allow us to ensure that the charges of the reaction are balanced. So for our oxidation reaction here, we have Fe2 plus going to Fe3 plus, so we need to add 1 electron to the right-hand side. With our chromate example, we've got a total of 12 on our left-hand side and a total of 6 on our right-hand side. So what that's going to mean is that we need to add 6 electrons to the left-hand side to make the charge 6+ on both sides. It is going to be necessary in this case to equalize those electrons, because in our oxidation reaction we've got 1 electron, and in our reduction reaction we've got 6. So we need to multiply that first reaction by 6. And then we're going to move on to the next step where we combine our two half reactions. So our oxidation reaction, our reduction reaction, we want to add these together. And in this case, the electrons will simplify and we'll have our full balanced reaction. Now, if in our oxidation reaction we also had to place water molecules in H+, much like your electrons would cancel, your hydrogen ions or your water molecules on both sides of the equation can either simplify or combine. Okay, so keep an eye out for those. Now, one thing that's great about oxidation reduction reactions is that we can verify our work. So we can verify that the atoms is the same on both sides as well as the charge. So in this case, we've got 14 hydrogens on both sides. We've got 7 oxygens on both sides. We've got 2 chromium, and we've got 6 iron, which is great. So now we want to balance the charges. So on the left-hand side, we have 14 times 1 plus -2 plus 6 times 2 for a total of 24. And on the right-hand side, we have 6 times 3 plus 2 times 3 for a total of 24. What you're going to see in future examples is scenarios where we have to balance an acid first and then add a few extra steps to balance in base.